we're going to talk about distance in the coordinate grid. Okay? Why are we doing it now? Because it's related specifically to the Pythagorean theorem. The Pythagorean theorem gives us distances of the sides of the legs and the hypotenuse of a right triangle. It gives us the distances on a right triangle, or the lengths. Length and distance, those are synonyms. So if I use the word length and I use the word distance, I'm asking you for the same exact thing. Okay? So we're finding the length or the distance between 2 points in the coordinate grid. The problem is, how do we calculate that? Say we have a point A, say we have a point B, somewhere random. This is some rando stuff. Okay, you don't have to write this piece down. We have 2 points randomly in the coordinate grid. We're going to give them random values. We're going to give them variables so that we can keep this generic and create a formula. Okay? Say those are our random values. That would be an X. We're going to label them purposefully like they're X1, Y1, X2, Y2. Okay, in terms of the coordinate grid, we need to calculate the distance. Oops, that's the wrong line to draw. We want this green line. We want that. And we're going to call it D for distance. Does that make sense? We're calling it X1 for one of the points, Y1 for one of the points, X2 for the second point, and Y2 for the other second point. How are we going to find that? Well, this is kind of tricky. I'm just going to kind of tell you. Can we find the vertical distance? And we can find the horizontal distance. Okay? The vertical distance is going to be subtracting the 2 y coordinates. Does that make sense? I'm going to just do y2 minus y1. Now, it depends on which one's bigger would be the order that you would do it in. Technically, it's the absolute value. I'm just not going to write that now for you guys because I don't want to get too confusing. The horizontal distance, we can subtract the 2 x coordinates for the horizontal. The left, right are the x's. So I'm going to subtract them. Right? Do you guys see a right triangle in the picture? Okay. With the right triangle, we know how to find the distances. If we know 2 of the distances, we know how to find the third distance. Because it's a right triangle, we can use the Pythagorean theorem to find the third distance. So that's what we're going to do. We're going to rock the Pythagorean theorem on this with these numbers, or these variables. Okay? So, most importantly on the Pythagorean theorem, we put the hypotenuse on the equal sign by itself. We also we take the other distances and we square them. Right? We add that we take that distance and we square it. X2 minus X1 is the distance, the horizontal distance. Right? We're going to square it. Then we add that together and we take the vertical distance. You with me? Our goal is not to put it in the Pythagorean theorem. Our goal is to actually find the distance itself. We want to solve it for D, so we're going to square root both sides. Now, again, we're going to do a little bit of, I'm not going to put one piece on it. Technically, there's a plus or minus that needs to go in because you're square rooting both sides of an equation. When you square root both sides of an equation, it's positive and negative values of the square root. However, we're talking about distance, which is always a positive value, so we're not going to put the negative there. That's our distance formula. That's what I want you to write down on this up here. Distance equals the square root. I'm going to change it a little bit and put x1 first just because I feel like it. It doesn't matter because they're variables. Recall that? You guys have done this piece. What you haven't done is you haven't put it in terms of geometry, which is like question 11, which is what we'll get to at the end of class. And all of your questions that you have to answer today, the big whopping 4 questions, those all involve geometric situations. We're bringing it to geometry rather than just algebra. When we're going to find distance, distance equals the square root, and we subtract the coordinates. We subtract the x coordinates and square it. So we're going to do -1 minus 2 squared. That's subtracting the x coordinates. We're going to add that to 5 minus -5 squared. Right? Minus in between. We're subtracting the coordinates in this case because we want the vertical and the horizontal distance, and then we put it in a strange form of the Pythagorean theorem. Then we calculate this. -1 minus -2 is -3. So we get -3 squared plus 10 squared. Now, contrary to what some people believe is the answer to this is not 13, nor is it 7. Okay, some folks like to put the square root on both of those things. You learned in algebra, this is a side note, that this is not equal to this. Hopefully you remember this. These aren't equal. Don't do that. That's bad. Anyway, so 3 squared is 9. 10 squared is 100. This is square root 109. And when we do our Christmas style factor tree, because it's in green and it's Christmas time, we can't really do much with that. It's going to wind up knowing that we can't, there's no common factors in there, so we can't reduce the radicals. So this is our answer for our distance between those 2 points. Square root 109. Okay. All right, let's pull down to 7. Yep. I'm going to go to 7 right now. Let's do nuts and bolts again. D equals square roots. Right? We're going to subtract the x coordinates. Then we're going to subtract the y coordinates. And maybe when you memorize this distance formula, you want to just memorize that piece and know that the x's go together and the y's go together. Simplify it a little bit if you're a visual kind of person. We're going to put the x coordinates in there. So we're going to do -1 minus 5 and 6 minus 0, which gives us square root 36 plus 36. Now I skipped a step, and that's the way I'm going to show it on my notes and my answer keys, because I don't want to show all the steps. I just want to show the necessary steps. Okay? Any questions I get in there? Then we do 36 plus 36, so it's square root 72. We do our Christmas factor tree. Then we look for pairs. So we're going to take the pairs. Getting distracted. All right, here we go. We're going to grab pairs. Pairs come out. Pair out. Pair of 3 come out as multiply, and this lonesome stays under. He's lonely. It's okay. I was lonely once. Sometimes I still feel lonely. I know I recorded that. All right, looking at number 11. Read number 11. Number 11 is asking us to determine whether this particular triangle is a scalene triangle. Now, lots of you guys would go do this, and this is not wrong. Graphing it is not wrong. I'm going to do it backwards. That's Z, 1, 2, 1, 2, 3, 4. I'm going to tell you right now, as a student, I would graph it. I would. I really would. 1, 2, 3, 1. Should you use graph paper? Unless you graph this incredibly accurately. The question is that scalene? What does it look like? It looks isosceles. I'm going to give you a spoiler alert. This triangle is scalene. Okay? It looks isosceles. I drew it misleading on purpose to prove a point. Fact is, that picture, remember we always talk about we cannot determine measurements based off of images unless we specifically tell you you can. I'm not telling you you shouldn't rely on an image for distances or measurements. So the question is it a scalene triangle? That's the purpose. We need distances to determine that. We need to know the side lengths. We need to know the side lengths. We cannot determine lengths from pictures, so do not use the picture to determine your side lengths. You got that? We're going to talk more about that in a second after we finish. So how do we do this? Well, we need to figure out the distances or the lengths of the 3 sets of sides. So we have 3 distance formulas to do. 3. I'm going to find the distance between x and y. That's what xy means without the line on top. So we're going to find the distance. We're going to put the coordinates in, and we're going to calculate the distance. Remember, we subtract them in this. So we're going to do x and y. We're going to put the x coordinates in their spot, and we're going to put the y. Then we're going to put the y coordinates in their spot. Any questions on that? This is where it comes into geometry, you guys understanding how to do this piece, referencing the distance formula in terms of the different shapes. So this becomes 25 plus 9 square root 34. Now, before you go all Christmas tree factor tree, reduce it, fantastic. If you wanted to, you could. Yes, do it. Why not? But the purpose of this problem is to determine if it's scalene. To do that, we compare the side lengths. We just need numbers for comparison purposes. We don't need numbers for their purity. Okay? So we're going to leave it as square root 34, even if we could have reduced it, because we're only using it as a comparison piece. Okay? You could get a decimal on this one as long as you round it to hundredths, because the purpose is comparison. The purpose is not finding the actual lengths of the sides. Does that make sense? You can be a little lazy on these ones. Then I'm going to find xz. Negative 3 minus 2 plus 1 minus negative 5, which is really plus. And we're going to crank that out. We're going to act like Showalter boy. Crank that. Yeah, that's right. I'm funny. Square root 61. We're okay to leave it there because the purpose is comparison. The purpose is not the distances themselves. And we're going to do the third set. Yeah, that's a bit of work. It's okay. You guys are tough. You can handle it. You have a big whopping 4 problems for homework. Right? Wait, where should be 0 plus 81, which is square root 81. Are those 3 lengths, are those 3 measurements the same size? Are any of them equal? No, they're all different, which means yes, it's scalene. Even though I drew it. Okay, listen carefully. Keep your stuff out. Listen carefully. I want to make a very big, important point. Make sure you don't mislead. You're not misled by this. Here's the deal. This picture that we drew is good for a general understanding of what's going on. This picture can give you the different segments. XY, YZ, XZ, right? It can help you line that up. That's okay with the picture. You cannot use that picture for distances or lengths. You have to go back over here to determine and use the distance formula to determine the actual distances. That's what you compare. Okay. If you choose to just draw the picture and then answer the question yes or no, or say it's scalene, and you happen to get it right, I'm only going to give you a point. I'm not going to give you 4 points for the problem. Why? You guys make sure you hear this. Why is this important? This is important because you're telling me you have a general understanding of it, but you do not tell me you actually know for sure that it's scalene. You need to tell me beyond a shadow of a doubt that it's scalene or a particular type of triangle. So you have to show this work. You have to show those distances. Let me relate that to something that makes more sense to you. When you're talking about research and you're going to go on record and make a statement about something, whatever that happens to be, you want to know your facts are truthful. A prime example for you guys that you've heard preach over and over again, if you go to Wikipedia, Wikipedia is a good spot to get general information. General information that you're not necessarily going to use as fact, right? If you go on record with something from Wikipedia and you say that it's 100% true and you go on record with that, you might get caught and it might be wrong and you might look like a total buffoon. Okay? Right? The same thing is true with diagrams that you draw yourself unless you construct them perfectly, and nobody in here is going to do that, including myself. Okay? Is that clear? You get 1 point, not 4. Please make sure that you